Get your free copy of the complete tutorial at www.teachucomp.com/free.
The relational model of data storage allows you to more easily and effectively model a complex entity or subject like sales. The relational model of data storage eliminates redundant data entry and also creates less data to store, making the relational database model smaller and faster than the flat file. When you create a relational database, you will first need to perform some data modeling. Data modeling allows you to ensure that you are recording all of the information needed and also helps you identify the entities involved and their relationships to each other. When you create a relational database, you need to identify the unique entities involved in the process that you are modeling. These entities will often become the various tables in your database. So, for example, in the sales database example from the last lesson, the customer is an entity. Within each table created for each entity, you must only list fields or columns of information which share a one-to-one relationship with the entity or subject of that table. So, for example, within a customer table, you would want to place the field first name, assuming that each customer only has a single first name to record. You would not want to place the column or field of item into the customer table, as the relationship between the customer and the items purchased by the customer is one-to-many. So what would one do with the field or column of item? In the relational model, each field or column of information is an attribute of an entity. For what entity is item an attribute? In other words, with what entity does the item, meaning a description of the item purchased, share a one-to-one relationship? Perhaps you may initially think that the item is an attribute of the sale. However, could you have a single sale with multiple items that are ordered? Probably so. In that case, it must be an attribute of something else. In this case, item is probably going to be an attribute of an item entity, meaning that you will probably need to create an item table. Many times when initially approaching data modeling, it may be easier to list the various attributes that you wish to record, and then try to find what entities the attributes describe. The entities will become the various tables in your database. The attributes will become columns within the entity tables. Remember that each attribute or column or field within your table must share a one-to-one relationship with the subject of that table, meaning the entity described. In either case, you should probably keep your information written down on paper until you have a rough idea of what information it is that you want to record about the various entities involved with the process or system that you are trying to model. It is a rare feat to have your preliminary sketch of a relational database table turn out to be the finished model that you will actually create within your RDBMS. Many times you'll need to create a model, look for problems within the model you've created, and then edit the design until you're ready to attempt creating the tables within the actual database. Let's take a look at the preliminary model of the sales database from the prior example. So first you would make a listing of the various pieces of information you want to record. These become the attributes of the various entities. Then try to find what entities these attributes describe and list those too. You can see a preliminary draft shown on screen. Next, make some sketches of the tables that show the fields of information within them. This can help you to start to visualize what tables you will need to create, and it will also allow you to see how the tables will eventually be related to each other in a larger relational database structure. Now, once you have a rough idea of what you would like to record and what tables you will need to record, you must then ensure that each table has what is called a primary key. A primary key is a column or combination of columns that will produce a unique value for each record or row within a table. Many times, an additional column is added to the tables in order to provide this unique identification. You can assign each record a unique number within a separate ID column or field. For example, that is what your Social Security number is used for by the government. You also have a unique driver's license number as well. Now, if you were recording any of those pieces of information within your database, you could use those as the primary key for a table. If, however, you aren't recording any type of unique information by default, then often you must assign your own unique values. Many companies, for example, will assign customer ID numbers in order to uniquely identify each customer. Let's look at how the data model will change once you assign primary keys to tables. For example, you need a way to uniquely identify each customer. In the current data model, there isn't any kind of information that would enable you to uniquely identify each record or row within the customer's table. So you could add an additional field or column of information to this table called Customer ID. Assume that you then add another column for Sales ID to the Sales table and an Item ID field to the Items table. So in the sketch shown on screen, each primary key field is shown in bold within the table diagram. So the data model would then look something like this as it's shown on screen. Now, the primary key is a very important concept in a relational database because it is through the primary key assignment that you are able to create the necessary joins or relationships between the data tables. For example, examine the relationship between the customers table and the sales table in terms of the one-to-one and one-to-many relationship. In this case, for each one customer, there can potentially be many sales. So the table will share a one-to-many relationship. This is the most common type of relationship that occurs between tables with extremely few exceptions. What you need to do next is find a way to join the many side of this relationship to the one side of the relationship between the tables. In other words, you need to relate each entry that occurs within the sales table to a customer within the customers table. In order to join tables, they must have a shared or common field between them. This would be a field that contains the same kind of data in both tables. So in this example, you're trying to assign each sale to a customer. To do this, you would want to add a field to the sales table that corresponds to a field within the customers table. Which field would you choose? The answer is the primary key field. Remember that each primary key field is designed to uniquely identify every single record in the table. So you can add a field to the sales table that will simply make a reference to the existing values in the Customer ID field of your customers table. That way, when you enter a record into the sales table in the future, you will only need to enter the Customer ID number of the customer to whom the sale was made, practically eliminating redundant data entry. So you can see one advantage of the relational model. In this model, you only have to enter the customer's data once in the customer's table and then assign them a unique customer ID. When you then enter sales for that customer into the sales table, you only need to make a reference to the appropriate customer ID within that sales record to indicate who made the purchase. This allows you to store much less redundant data, making the relational tables smaller and faster to use than the flat file table. It's also important to note that the Customer ID field, which is added to the Sales table, is not a primary key. That table already has its own primary key field within the Sales ID field, which uniquely identifies each sale, like a receipt or invoice number. Technically, the field in the Many table, which makes a reference back to the primary key in the One table, is called a foreign key. Its only purpose is to relate the two tables, and the values within a foreign key are almost always non-unique within that field or column. Now don't worry about the mechanics of the data entry yet, or how to create primary keys or table joins just yet. This will be explained in later lessons. For now, just try to comprehend the concepts and reasoning behind the relational database design. So let's examine how the table diagram has changed to reflect the newly created relationship between customers and sales. Next, you will want to examine the other relationships between the tables. For example, what is the relationship between customers and items? Don't be hasty. Not every table in the database has to be directly related to every other table. The only way that customers and items are related is that the customer purchases the items when making a sale. The customers and the items do not have a direct connection. However, in a relational database, as long as every table is connected in an appropriate manner to the correct table, you can find out how they are related to each other through the tables by which they are connected. So in summary, the customers are connected to the items, but only through the sales. So, how are the sales table and the items table connected? Well, for each sale, there may be many items ordered. Also, each item may appear in more than one sale. In relational database design, you cannot or should not create a many-to-many relationship. That would make no sense from a strictly logical point of view. You need to be able to tell which items were ordered in which sale while reducing the amount of data entry. Also, you may notice another problem with the current data model. The amount field is attached to the sales table. So in this context, the field would be the sales total. If that's the case, then how can you record the price of each item at the time of sale? What if the price of each item changes in the future? Is the amount also an attribute of the item? What you are starting to see is that you need to be able to link the unique sales records to the unique items ordered on each sale. You need a sales details table in order to do this. But what fields do you place into the new sales details table? The answer is anything that is an aspect of the many side of the sales transaction. For example, the sale date field can stay in the sales table because each sale only happens on a specific date. The quantity of the items purchased at the time of sale is actually part of the many aspect of the sale and should be moved into the new sales details table along with the amount field. The customer ID will stay tied to the sales table as each purchase is made by a single customer. So now examine how this new sales details table will affect the data model being sketched. You can see a diagram of the new tables in the data model shown on screen. You must also remember that the new table of sales details will also need to contain its own primary key field. Before assigning the primary key field, look at how you will relate the sales table to the sales details table. The tables are related in that each sale may have one or more items purchased in each sale. So you need to join each record in the sales details table to the sale record to which it corresponds. To do this, you will add a foreign key into the sales details table that corresponds to the data in the primary key within the sales table. Therefore, you will add the sales ID field into the sales details table. Next, examine the relationship between the items table and the sales details table. In this case, for each item ordered in a transaction shown within the sales details table, it must make a reference to a unique item within the items table. So you will add the foreign key field of item ID into the sales details table as well. Then you can join the tables through their shared or common fields. Let's examine how the data table diagrams within the data model may look after performing these two tasks. Now you have created all of the necessary relationships between the tables. However, the sales details table is still missing a primary key field. You could add another field as the primary key, such as sales detail ID. However, you could also see if there is a combination of field values that already exists that, when combined, produce a unique row or record value. In fact, there is. The combination of sales ID plus item ID. There should never be a repeating combined value within those two columns. If there were, it would mean that the same item was recorded in the same order twice. If that were the case, it should only be recorded once in the sales details table with a 2 in the quantity field. So assuming that you make this combination of fields the primary key for the table, let's re-examine the data diagram. Now this is the final data diagram based on the information that was needed to record the sales. Obviously there is more information that could be recorded, but this example is only supposed to illustrate some of the decisions that should go into table design before you begin to create tables in a Relational Database Management System, or RDBMS.
Like what you see? Pick up your free copy of the complete tutorial at www.teachucomp.com/free.